Starting with a segment of a circle, such as ABC, we would like to construct the rest of the circle and describe how the segment relates to the circle. Meaning, is the segment less than, equal to, or greater than a semicircle? Let's bisect AC at D and draw DB to be perpendicular to AC and connect AB. Euclid identifies three cases. The first is when angle ABD is greater than angle BAD. The second is when they are equal. And the third, when angle ABD is less than angle BAD. Starting with the first case, draw AE so that angle ABD is equal to angle BAE, and connect DE and CE. Triangle BAE is an isosceles triangle, so AE is equal to BE. We have two other triangles, ADE and CDE, where AD is equal to DC, because it has been bisected at D. DE is common, and angle ADE is equal to angle CDE, because BD is perpendicular to AC. Therefore, the two triangles are congruent, and AE is equal to CE. We have thus identified three lines that are equal and that intersect at a point E, and also lie on the circumference part of the segment. This means they are radii of the circle with center E and radius EA. Since the center of the circle E is outside of the segment, it is clear that the segment is less than a semicircle. Moving on to the second case, where angle ABD is equal to angle BAD, we have the isosceles triangle ABD, so AD is equal to DB, and also DC is equal to AD, since AC was bisected at D. So as before, we have found three equal lines that meet at D and also lie on the circumference part of the segment. Therefore, these lines are radii of the circle with center D and radius AD. Since the center of the circle D is on AC, the base of the segment, we know the segment is a semicircle. In the third case, we have angle ABD less than angle BAD. Let's draw AE so that angle BAE is equal to angle ABE. Now, Euclid stops here and draws his conclusions, but I needed to add a couple more things to feel convinced about it. Let's draw EC. Since triangle ABE is isosceles, BE is equal to AE. Looking at triangles AED and CED, AD being equal to CD because AC was bisected at D, they share ED, and angle ADE is equal to angle CDE because DE is perpendicular to AC. This means the two triangles are congruent, and EC is equal to EA. Just like before, we found three lines intersecting at a point, E, that also lie on the circumference part of the segment. So, these three lines are radii of the circle with center E and radius EA. Since the center of the circle is inside of the segment is greater than a semicircle.